Okay, this is just going to be a quick review of difference of squares, factoring difference of squares, and then, more importantly, factoring differences of cubes. So let's just start with difference, and let's do the sum of squares. Okay, so this is actually an Algebra 1 thing, but say you are faced with the task of factoring, let's do 4x squared minus 36. Let's do that, okay? So there's two different ways you could factor this. What really is going on here is you have 4x squared plus 0x minus 36. So you have several options then about how you want to factor this. So if you're really good with our x method, we go ahead and do that. We want it to multiply to 4 times negative 36, which gives us negative 144. And then we want it to add to our middle term here, okay? And the reason this is 0x is because the term's not there, and anything times 0 is equal to 0. So we're just kind of bringing it back in to understand what's going on here. So we want it to add up to 0. So that means that we want them to have opposite signs, so they cancel out, and they should be the same number. Well, I know the square root of 144 is 12, so negative 12 times positive 12 gives me negative 144. And negative 12 plus 12 gives me 0. So splitting into groups, we have, I'm splitting this term. And if you have forgotten how to do this part, then go ahead. I made another video about that, so you can go watch that video. All right. But now I'm taking GCFs out of my front and my back. So I'm pulling a 4x out of here, which leaves me with x minus 3. And then over here, I can take out a 12. So I'll pull out the 12. Which leaves me with x minus 3, okay? So here's one term, 4x plus 12. Here's another term, x minus 3, okay, right here, the repeated term. So here, I'm not done. I have a GCF here, so I need to take a GCF out, okay? So I'm going to pull out a 4 from this. So 4 times x plus 3, x minus 3, okay? This here is the standard form of this that we've seen before, okay? Now, if we wanted to look further at this standard form that we've seen, okay, let's do this a second way, all right? So the other way we've seen this is the square root of the first term plus the square root of that second term, okay, times the square root of that first term minus the square root of that second term. Okay, so let's go ahead and do this. So what is the square root of 4x squared? Well, that is 2x, okay? And what is the square root of 36? We're kind of ignoring the sign right now because we don't need it right now. Okay, well that's 6. So I have 2x plus 6 and 2x minus 6. All right, now I can see looking at this, I have a GCF in each one of them. So I'm going to go ahead and pull that GCF out. From here, I can pull out a 2. I get x plus 3. From here, I can pull out a 2, giving me x minus 3. Okay, so I'm going to combine my like terms here. 2 times 2 is 4. I get 4 times x plus 3, x minus 3. Okay, and here it is. There's that standard thing, right? Here's our plus, here's our minus, and there's our squares, okay? Now this is hinting at, all right, I could have taken that GCF out on the first try. So let's go ahead and do it if we take the GCF out on the first try. Okay, so I can see from here, I can take a 4 out. So there's 4 times x squared minus 9, okay? And from here, I can split this, I can break this into difference of squares. So that's 4 times x minus 3, x plus 3. And then I'm done. See how easy that was? Just recognizing that pattern. Square root of x is x, square root of 9 is 3. Okay? So, sum of squares is a little bit different. Not too much, though. Let's add. Okay, sum of squares, let's say I had two problems here, so 4x squared plus 8x plus 4, and then x squared plus 6x plus 9. So again, here's my really easy. I see that I have a GCF in there. 4, 8, 4. That's screaming 4 at me, so I'm going to go ahead and pull 4 out. So x squared plus 2x plus 2. I mean 1. I can math. Okay, and so then from there, I'm keeping my 4 outside, factoring in here. All right. I want something that multiplies to 1 but adds up to 2. So that automatically shows me 1 and 1. So x plus 1, x plus 1. Okay? So those aren't too tricky. Those are barely even a pattern recognition. That's standard factoring, okay? And here we have the x plus 9. I can see that's a square of 1 So just x, and this is the square root of 9 is 3, so x plus 3, x plus 3. Okay, so that's sums of squares. Really no big deal. Now let's do cubes, because, yeah, cubes, those are fun. So let's say we have x squared minus 27, not squared, cubed. X cubed minus 27, x cubed plus 125, and then let's say x cubed, no, let's do 2x to the fourth minus 250x. Okay, so my sums and difference of cubes. So here I'm looking for, I have my pattern that we talked about. Okay, that's a minus b times a squared, opposite sign, because remember we want to cancel everything out. So plus a times b, and then plus my other term squared. So, and I'll explain this as we go in a second. All right, the other form is a plus b, all right, if you have a plus, and then a squared plus, no, not plus, opposite sign, minus ab plus b squared. Okay, so here I'm first going to take the cube root of each piece of this. I see that I have cubes going on, so I know I can use my difference of cubes. So cube root of this gives me x. Cube root of 27, keep the sign, gives me 3. Okay? Now, how do I go from x back to x cubed? What I need to multiply by? Well, I need to multiply by x squared. Okay? So that's where that a squared comes in. Then I have negative 3. Well, I need to go from 3 to 27. So in order to do that, I got to multiply by 9, which just happens to be 3 squared. So 3 times 3 times 3 gives me 27. Now in the middle, I needed to cancel everything out, and the way we do that is with our 3 times x. Boom. Okay? Now this can be proved by polynomial long division, but the easiest way to do it is to remember it, because polynomial long division is clunky. So over here, we have x plus 5, okay? Same thing, cube root of x cubed, x. Cube root of 125, 5. Plus, I keep the sign. Now, I need this term squared, x squared, plus, not plus, opposite sign to cancel everything out, 5 times x, and then we need to multiply 5 by 25 to get back to 125, so plus 25. Okay? Boom. Got it. Okay? Here's a more complicated one. All right? The key is that I'm just looking to identify anytime something has been cubed. Okay? So here I know 27, well, that's 3 cubed. Okay? So I'm just going to guess, let's say this is difference of cubes. Let's check to make sure it'll work. Okay? That's 3 cubed. That's y squared cubed, giving me y to the 6th. That's 2 cubed, and that's x cubed. Okay? So everything's cubed, so it'll work. Okay? So the cube root of 27, 3. Cube root of y to the 6th is y squared. Keep my sign. Cube root of 8 is 2. Cube root of x to the 3rd is x. Okay, so I make my first term, and now let's make my second term here. Okay, I got to square this first term. 3 times 3 is 9. Y squared times y squared is y to the 4th. Opposite sign. 2x times 3y squared gives me 6xy squared. And then negative 2x, I got to square this 2x here, so plus 2 times 2 is 4. X times x is x squared. Boom. See, I just following the pattern over and over and over. There's no tricks going on here, okay? This one, okay, it looks like, how the heck am I going to factor that? But the golden rule of factoring is to look for a GCF, okay? So what's the GCF here? 2. Got an x in both terms. X, pull that out. Okay, what's left? X cubed minus 125. Oh, that's beautiful. Those are cubes. Awesome. So I get 2x. This is going to give me cube root of x is x. Keep the sign. Cube root of 125 is 5. And now, follow my pattern. I need a squared, my first term squared. So that's x squared. Then opposite sign, 5 times x. And then plus 5 times what gives me 125? 25. Okay? And that's sums and differences of cubes. Is that easy? Okay? it's just a matter of working at it, learning it, watching this video a million times if you need it, and learning these patterns, okay? So, that's sums and differences of cubes, review of sums and differences of squares. Hope this helps. Thanks.